Hello everyone, welcome back to WAYN Games for this episode on animating with Dots 1.0. In the previous episode, we have set up and spawned a free asset with entity command buffers. Today, we will learn how to animate this asset even though the Dots animation package is not released yet. Thanks to the hybrid approach, we will be able to use GameObject in tandem with entities to reach the result you see now on screen. This approach allows us to use GameObject features such as animation, audio, and VFX, while their Dots version isn't ready yet. For that, we will use two new components type and make use of Reactive System. So get ready, this is going to be a tutorial packed with information. Okay, the first thing we want to do is finish and test our asset setup. At the end of the previous video, we imported the asset and made sure it rendered correctly in a URP project. I can't distribute this asset, so it's not part of the GitHub repository. So if you don't have it set up, go check out the last video. Now, we will set up the animation. In the work animation, enable the loop option. Then, in the prefab folder, create an animation controller, drag the walk animation in the controller, and add a float parameter speed. We will use it later in the video. Finally, set the controller on the skeleton prefab. If you drag it in the scene and enter play mode, you should see the skeleton walk in place. This will serve as the presentation layer of our entity. Since dots cannot yet animate skinned mesh in a friendly way, we will split our enemies in two parts. The simulation part that handles the movement using an entity, and the presentation part that handles rendering and animation using a GameObject. The next step is to modify our enemy authoring component and Baker to reference this presentation prefab. In the authoring component, add a GameObject field so that we can access it in the Baker. What we want is for the entity to spawn its GameObject representation at runtime. For that, it needs to keep a reference to the prefab GameObject. But since CCS component can only contain blittable type, we can't store the GameObject in one of them. Or can we? The trick is to use a manage component. Manage component or class component as opposed to the unmanaged struct component we have been using until now. They allow to reference any type of data, but the downside is that you can't use them outside of the main thread or in a burst compile context. Make a manage component for the GameObject prefab. In the Baker, we will add the GameObject prefab to the manage component. Now, let's make a system to instantiate that presentation GameObject. We are working with manage type, so we can't use burst, but we can query the manage components the same way we query aspects. What we want this system to do is instantiate the GameObject and remove the manage GameObject component. This is to avoid creating a new GameObject every frame. Systems that are executed only once because a component present are called reactive systems. They react to a set of components. Then they either add or remove a component from that set to indicate that the system already executed on that entity. Go back to Unity and set everything up. When you enter play mode, you will see your animated skeleton appear, but they no longer follow the path. Looking at the entity inspector, we see that the entity still moves. That means the position of the presentation GameObject is not synchronized with the position of the entity. We will take care of that as soon as you have hit the like button. Go on, I will give you a moment. Thank you. Go back to the presentation GameObject system, make two new manage components, one for its transform and one for its animator. We don't add these two components to the Baker because we don't want a reference to the prefabs component. What we want is a reference to the components of the instantiated presentation GameObject. store a reference to the animator, and transform component on the entity. We store references to the mono behavior and not the game object to avoid calling the getComponent method every frame. In the system, make another for each to synchronize the position, rotation, and speed of the game object with the entity. Before going back to Unity, I want to do a couple more things. I want the entity to look at where it's going, and I want to destroy the entity when it gets to the end of the path. I'll make a method in the pathFollower aspect and use it in the moveISystem to destroy the entity. Okay, now in Unity, we enter play mode and see our skeleton walk the path. They are sliding a bit so we can tweak the animation speed. Something between 1.4 and 1.5 should do. Great, but there is still something wrong. The skeleton stops moving at the end of the path, but they don't disappear and are still animated. Likewise, if we destroy the skeleton game objects, we get some unwanted behavior. How can we synchronize the destruction of the game object and the entity? Let's first see how we can destroy the entity if the game object is destroyed. We will make a new mono behavior, add two private members, one for an entity and one for the entity manager. The entity manager handles all the operation on entities. It is used by the entity command buffer when executing the queued commands. Create a new assign entity method to assign those members. Then, in the onDestroy method, destroy the entity. Don't forget to call the assign entity method when creating the presentation game object. That should take care of deleting game object in the scene. Now, how to destroy the game object if the entity is destroyed? We could do it in the moveISystem, but later we may also want to do it when the enemy gets killed by a tower. We don't want to duplicate the code, and aspects don't support entity command buffers. The correct solution is to use a reactive system. But how can we react to an entity that no longer exists? We need to use a iCleanup component data. It is a special type of component that persists after the entity destruction. This allows us to make a reactive system to detect when an entity is destroyed. We can apply it to the transform manage component, and when the entity is destroyed, it is left with that component, but no longer has any other components. We can make a query that matches those criteria to destroy the presentation game object. Finally, remove the component from the entity to complete its destruction. Go back to Unity to test it. Great, it starts to look like a tower defense. Next step, placing some towers. Thank you for watching. As usual, like, share and comment. And if you feel like it, come hang out with us on Discord. See you in the next video.